So it'll actually just take a little bit to get through this first part, and then we can talk more about it, and everybody's kind of up to speed on what blue on is. Does everybody know what refrigerant is? Right? Okay. Mark. All right.
Makes things cold, right?
I like the more intimate size. This is good. I'm glad it's actually worked out like this. So what we're going to talk about here is we're going to talk about the phase down of refrigerants. We're going to go through history, the phase out of HCFCs. We'll talk about what that is. Consumer options, refrigerants future, new 608 rules if there's time. That's up to you guys if we want to get into that. R290, which is a new refrigerant that's out there. It's flammable, highly flammable. And then that's if there's time or if you guys want. And what we're not talking about is flooded evap equipment. So chillers, centrifugals, things with a flooded evaporator where it's got a big barrel. We're not talking about those. So those are manufacturer specific. They have engineered options. So Trane, Carrier, York. Not to say we can't do them, but that's not what this presentation is. This is more your split systems, your package units, your unitary systems. So that's kind of what it is. So some of you were here in '96, went through this. Maybe not Dan. I was on the tail end of this. We phased out CFCs, chlorofluorocarbons. That's CFC. 96, we got rid of the R11, the R12, the 113. Turned out that it made a hole in the ozone layer. I was in high school. I remember seeing the hole. It was all over the news. It was a big deal. And what they determined was that those CFCs, they get up in the atmosphere, the sunlight reacts with them, and it destroys ozone. Ozone protects the Earth from UV rays from the sun. And it was letting too much in, and we had global warming. So they brought in HCFCs. Those were going to be the magic potion. HCFC, that's your R22, hydrochlorofluorocarbon. They added the hydro. That's your 22, your 123, 401, 404, 402, 408. Some of those look familiar to you. 22, of course, is the most well-known, but there are others.
Anything that the R11, that I could buy it for $100 a pound for my old car. All that stuff is just reclaimed. It's just been scourged up.
R12, like R12. So R12 is used in cars for a long time. Anything pre-2000 possibly had R12. Probably 94 and below, something like that. Most things around 94, 95, they went to 123.
So what's R12? So
yeah, it was R12. But it's still out there. Yeah. There might be people in this room with a jug in their garage. Like, I know people that have it in their garage because they thought, oh, this is going to be liquid gold. Yeah. And so it's sitting there, and then it turned out it's not really worth anything.
Not unless you go to a car show.
But it's out there. So we went to R22 HCFCs, and then it turned out these are really no better. And we need to go to something else. So the government, the industry has known that for a long time. I can remember 18 years ago going through a class on 410A. 410A is an HFC, hydrofluorocarbon. They got rid of this C right here. C is for chlorine. They dumped the chlorine. Turned out the chlorine was really causing a lot of the problems in the atmosphere. Contributes to global warming. So now we need to get rid of HFCs. We got rid of HCFCs, phasing out. We're going into HFCs. But these already have a phase-out date. So as of 2024, right now, no new equipment can be sold with 410A, 134A, 407C, all that stuff.
As of when?
2024.
6 years from now.
California's pushing for 2021. If California gets their way, there's a possibility of the dominoes kind of sweeping across. But it's so fast. I mean, I don't know how it could happen that fast. But it's possible. So the next refrigerants after those go away is going to be these HFOs, hydrofluoroolefins. They have zero global warming potential, and they have zero ozone destruction capability, or very low. they're equivalent to CO2. Everything gets compared to CO2 because CO2 is a natural gas. You hear about CO2 emissions being harmful, and they are, but they're still natural. They're better than these things. These things might have 1,200 times CO2 destruction, maybe more. They're thousands of times more dangerous than CO2, even though CO2 is kind of a big deal, but those are worse. So we're going to these HFOs. They're coming in now. If you open the hood of a very new car, you'll see like this 1234 YF. That's what comes over, like all Mercedes, some Chryslers. There's some, they'll be in the newer cars. So HFOs are out there, and that's what we're going into. The thing is, what we're finding, or what happens is, we can't jump HFCs. We can't go from equipment sold with R22 and put these in it. And I'll get to why here in a little bit. So what we're doing is this whole class revolves around HFCs, getting rid of those, and bringing in, or getting rid of HCFCs, bringing in the HFCs, even though they already have a date, an expiration date. So this all started with a thing called Montreal Protocol. You've all probably heard that before.
Is that in relation to retrofit?
Yes. Yes. There was a meeting. They said we need to bring levels down starting in 2015. You start reducing these levels of HCFCs, and we want to have them down to almost zero by 2020. After 2020, there is no more importation of R22. You're making of. So virgin R22. That's the big one that we're dealing with. There's others. There's this 142B and stuff, but we don't really get into that. So what that looks like is, it used to be we had unlimited supplies that could be made of R22. Supply demand, right? So we had a ton of supply. Things were cheap. Well, Montreal Protocol came in and said you need to cut whatever your production is for 2014. You need to basically cut it in half. And then you're going to continue to cut it all the way to 2020. So right now, that's where we're at. This year, they'll be done. The major manufacturers, Chemforce, DuPont, Honeywell, they're going to be done making it for the year probably in the second week of February. They start on the 1st, they make it for about 6 weeks. Last year they made it for about 8 weeks, and then they're done for the year. They'll probably make it 6 weeks this year, and then they're done, shut down. So whatever is made gets out there.
Valentine's Day.
Supply houses get their allotment. RSD gets a certain amount. United, Johnstone, they all get an allotment, and away they go. So what that looks like, supply and demand, we used to be able, I remember, and I'm not that old, but I remember being able to go to RSD and buy a 30-pound jug for about 30 bucks. I'm sure it was cheaper at one time before that. And it stayed pretty cheap for a while until we had this, they knew that this was coming, and it started climbing, had a jump, and then it started climbing. So we're somewhere right here right now. It hasn't climbed as much as projected originally.
For 30 pounds?
For a 30-pound cylinder. Yeah, one green jug. Everybody should be familiar with the green jug. So whether that's going to happen this year or not, I don't know. We'll talk about prices and where we're at today here in a few minutes. But that's basically, as our supply goes down, our demand goes up, and therefore our price. So that's where we're at. So there's options for customers. This building, this was all R22 equipment. Upper building, all R22 equipment. A lot of buildings. I mean, this stuff was made for so long. It was the golden juice, It was cheap. It worked well. It went into everything. So there's thousands and thousands of units that are out there. Some of this, they have some options. They can do nothing. They can leave them. There's no law that says you can't use R22. We just can't make it. So there's no law saying you can't have it. There's a law that says you can't bring it in on the back of your truck from Mexico, but you can't. There's no law that says you need to get rid of it. So you can do nothing. You can remove the 22 and put a retrofit refrigerant in. The reason that you would do that is because it extends the time that you can get the refrigerant for cheaper. Right now, the HFCs, remember we talked about there is no there's a date for when you can't buy new equipment, but there is no date when you can't buy the refrigerant. It's just new equipment. But remember, we went through this in 2010 with R22. 2010,
Stop making the new equipment, and then they.
Yep.
Then the production of the stuff tapers off.
pretty soon we had dry units for a while, and
Years, and
then,
you're right back to what they're saying.
yep, so it'll
It's
happen.
a projection.
So you can remove it and try to buy yourself some time, put something else in there, or you can replace the equipment. So we'll go through and kind of talk about this. The do nothing, the good part about doing nothing is nothing works better than what shipped in the unit. There is no magic juice. Mark mentioned Blue On. There's a lot of claims out there that what you can take out R22 and put something in there that's going to have more capacity for less money. And it's not true. It just doesn't happen that way. So if you have equipment with 22, it's going to run the best. If it's at your house, if it's on your business and it's running good, what's your risk? You know, do you have a high tolerance for risk? Leave it. Deal with it. If you're worried about it, or like CBRE or some of the property managers, they want to do something about it. You may have a piece of equipment that was built in 2010 that has R22 or 2009, so maybe it's only 8 years old. You might have some life left of that thing. And you can use that time to budget, figure out what you're going to do. So customers don't have to get super antsy about it, but it's something to think about. The bad part is R22 it's about 23 bucks a pound right now. Yeah, I think it's come down a little bit. We'll look, but it's getting expensive, and that's wholesale, so we're going to mark that up. So if you have a blowout of a circuit that holds 100 pounds, that's going to get expensive real quick. Maybe you can afford one blowout, but what if it happens again? Like it's your risk tolerance. You figure for non-techs, for the salesman, I tell them about 1.5 pounds per ton. So you got a 10-ton unit, you're about 15 pounds of refrigerant. So you can kind of do the math from there. Liebherts tend to have a little bit more refrigerant in them. Other units tend to have a little bit less. Property managers, I know when we met with CBRE, Tom Ripley, he'd said they see this as a liability. If you got a strip mall and you got 10 package units on it, and each one of those has 10 pounds of gas, that's 500, or that's 100 pounds of gas or whatever. It's a liability is what it is. So when they're looking at buying a building, they look at that and they say, well, that's a liability. Do I want to buy that? Do I want to take on that liability? So there's reasons to get rid of that refrigerant.
He was also talking about counting problem with it too, that as the values started spiking up, that they'd have to actually identify it
It's
on the
income.
books. Yeah.
It's income.
Yeah.
Yeah, accounting's weird. I don't know. So if you lost a charge, you got to deal with it. And in 2016, suppliers ran out of R22 in certain parts of the United States. We didn't over here. McDonnell Miller was buying this stuff by the pallet. We still had some. There were some suppliers. I know Johnstone Supply in Spokane was out. I heard RSD was getting low. So 2017, we didn't have that problem. I don't know what's going to happen with 2018. But that's one of the problems with doing nothing is you have this large unexpected loss of refrigerant. You can't even get the stuff. And now you're in a pinch because doing a retrofit, as we'll talk about, isn't always just a slam dunk. You may not be able to do it on a Saturday on call. Like there's certain things that go into it. So that's where the budgeting, the planning comes into play. So the good part about doing a retrofit is you're planning. You have time, you can gather what you need. We'll talk about those parts, but you can gather the necessary parts to do a retrofit. You can do it on your own timeline, do it on a weekend, do it at night, do it when it makes sense, just like anything, planned maintenance. You don't have to worry about the R22 shortage. That's pretty big. Some equipment was designed for alternative refrigerants. There's a lot of Trainum telepacks made in the late 90s up until about the mid 2000s that shipped with R22, but they could have had 407C in them just as easy. So doing that conversion may be pretty simple. R22 has been known as a compressor killer forever. It's got high discharge temps. Eventually the oil converts over to carbon and you lose the compressor. Retrofit refrigerants tend to have a lower discharge temp, so you may get some more life out of compressors, maybe. Suppliers buy back R22. So that's a selling point. If we can go in and take the refrigerant, say you have 100 pounds of R22, it's clean, we know it's clean, we can take it out and sell it to Hudson for 12 bucks a pound. And then we can knock the cost of that, we can share that with the customer, and that saves them some money on their retrofit. But if you wait until the compressor goes out or until you blow a hole in the coil, now you've lost all that money. Another good reason to plan. And
that's gonna continue to get you a better and better deal.
Yeah.
Every 6 months.
Yeah, absolutely. And then large multi-circuited units, by that like Train and Telepacks, Lieberts, whatever. We've done individual circuits. So you have one circuit running on R22 and one on 407C. So if you have a customer that's leery about it or maybe wants to take their time, we can do that. We have done it, so you can compare, and I'll hand out some paperwork in a little bit and look at some things. We've done some pretty good tests to kind of compare the refrigerants. This is a part from the chart from the Department of Energy. I think it seems a little generous, but it basically what it's saying is that based on the size of your unit, of your system, you can count on about a 20% loss of charge per year. That seems high to me, but maybe if you averaged it over the lifetime of the unit, maybe you could build a case for that 20%. But what it's saying is that on smaller systems at the current prices, it probably doesn't make sense to convert that unit because the cost of conversion versus the amount of refrigerant that you use on a yearly basis may not pay for it. But as you get bigger, that definitely starts to pay for itself. And as the cost of R22 goes up, these are gonna get smaller and smaller. So maybe eventually a 7.5 ton unit is worth converting because the price is so high. But if you were to take this on its own, maybe it's not worth it. But if you have 25 of these, now it's probably worth it because that's how much tonnage you have on your building. So it's something to think about because as a property manager, they have to think about their buildings as a whole, their campus. So there is a bad part about retrofitting. There could be a drop in unit efficiency on design days. Design days, that's generally 100 degrees outside air temp, 80 degrees inside, something like that. Those are design days. We don't have a lot of design days in the Northwest. Most of our equipment is oversized, so this really doesn't matter. The testing that we've done, we've never seen 10%, but we don't have those temperatures either. Eastern Washington, maybe. But there's some things to think about when you're proposing these. Efficiency, energy efficiency will probably go down. If it was built for R22, it works the best on R22. So compression ratios change. That changes the amp draw on the compressors. So that's your energy efficiency. Warranties will be voided, but I mean, this is all older equipment for the most part. So warranties isn't a big deal. And then parts required for the conversion, which we'll get into. You have to, sometimes they take a while to get depending on what you need. If you're converting a 30-year-old Mammoth vertical self-contained and you need a liquid line solenoid valve, maybe you can't get it. Maybe you got to do something else. I don't know. We'll talk about it. Then, of course, the last unit replacement. What you're buying today has 410A in it, and you're going to be in the same boat again in 6 years. So that's kind of the downside. And then if they decide to ratchet up that schedule, then they may be in a pinch even sooner. So, but I think it's a good idea to replace. There's benefits, there's efficiency benefits, but it is something to think about. So what are we doing? McDonnell Miller, we've standardized on 2 refrigerants for conversions, 422D and 407C. 407C is probably pretty familiar to you. Liebert's been using it for a long time. Train's been using it for a long time. Several manufacturers. R22D may not be as current with you. You may not recognize it as much. Both of these are Honeywell products. We did that on purpose because there are refrigerants out there made by different companies that we don't know what's going to happen in the future if they decide to quit making them, if the price all of a sudden goes up on them. Like we wanted to partner with a company that had a good brand name and had some like recognition. So that's why we went with Honeywell. Because like there's another company that makes 422B. It's almost the same formula, but it's not made by Honeywell. It's a different proprietary blend. Well, what if they quit making it? And then we're kind of scrambling. We wanted somebody that's going to be around. Honeywell's going to be around. So if it's if equipment is larger or you're doing a compressor, we say 407C all the way. The difference is 407C can only be used with synthetic POE oil. It doesn't mix with mineral. Most R22 units ship with mineral. So you cannot just take R22 out and put in 407C. It doesn't mix with the oil if it's mineral. That's why we have this option. 422D does mix with mineral oil. You can basically take it out, take the 22 out, put the 422D in. There's a couple other things to consider, but we'll talk about them here in a few minutes. Span.
So if you retrofit that unit with 422D,
Mhm.
and 6 months later that compressor goes,
Yep.
are you switching it over to 407C?
I think you'd have to. Because the way it is, right, mineral oil's basically dead.
So they're twice.
Yeah. It's cheap though. We'll see. If you order a compressor from Trane or RSD, it's either coming dry or with POE. There's very few that come with mineral. So that would kind of be a special order, or you're adding it yourself. So if you got a compressor that dies, the new one you put in is going to have POE in it. Just put 407C in it. It's simple. But if you got a unit on a roof that loses a charge, and you find the leak, you fix it, and you want to just gas it back up, well, that's your option here, 422D.
So how many jugs are we gonna have to carry in our truck?
16, 17? No, I don't know.
Because you would think that you're gonna have to have 22.
It gets worse. So we'll get there. We'll get there.
Okay.
Yeah, you're gonna have a trailer,
Okay. That's what I have.
probably. Yeah, that's why you have a driver. Yeah, what are you talking about? Be in your
Full bottle
Mercedes.
But 422D on 10 ton and under.
So here's the deal with the 10 tons. We say 10 tons because we, as McDonald Miller, are viewing R22D as a residential light commercial refrigerant. But there's nothing that says it is. It came up, Daryl West, I don't know if he read it, but he saw it, he sees it as a residential refrigerant. And I agree with him, because you don't see 422D in new equipment. You don't see it in commercial equipment. It's a retrofit refrigerant. So I do agree with him, but it doesn't say that you can't use it above 10 tons. That's not what we're promoting. We want to, if it's going to be bigger, we want 407C in there. Because as you get bigger, it's going to be a semi-hermetic compressor. It's going to have an oil drain, and we'll get through the specifics.
But as far as that Miller is concerned, our policy is going to be 10 tons and under.
That's what we're recommending. Now
Our hands won't necessarily be tied
No.
to that, but that's going to be the recommendation.
that's the recommend. You're not even tied to this. This is just if anybody asks, this is what we're recommending. But you guys are journeyman service technicians, most of you, some of you. So you can make your own decisions, but as far as a standard goes, this is what we wanted to standardize on. So we're about $6 to $8 a pound for these versus 22 for R22. And this was as of, I forgot to put that in there. That was 2 days ago. I got a quote from RSD. So that was my reminder to fill that in, and I failed to fill it in. So I apologize for that. So you can see we're about a third, almost a quarter of the cost, and that's we're thinking this is probably gonna stay fairly consistent, $6 to $8 a pound, where this is probably gonna go up. So as this delta, as this increases, that's where the retrofit comes into play. Now, R22 hasn't gone up much in the last year. It went up to almost $30 a pound a year, 14 months ago, and then it came back down. And I don't know if that's because more people are reclaiming, they're bringing back refrigerant, maybe more people are replacing, I don't know. But something's happened where the pricing has come down and kind of leveled off. But I think it's kind of a calm before the storm, but we'll see.
So does reman 22 have to be sold as reman?
They used to be, if you went to RSD, you could walk in and you could buy a jug of virgin R22, or you could buy a jug of reclaimed, redistilled R22. Purity levels are the same, but one's been brought back, cleaned up, and resold. One was virgin. Now they just sell them all at the same price. It's all. They may still have a sticker on one. No, you don't. It's all the same. It's all the same anymore.
So it's gonna look like virgin.
Yeah, you probably won't know any difference, right? Exactly. So we converted this building to 422D. We did every unit on it about a year ago, right before the summer, and everything's ran fine. Guys took out the gas, put in the 422D, took out the R22, or put in the 422D, and it's been fine. Not that this is a huge heat load building, but upstairs, the second floors ran all winter. It still runs in cooling. You'd think it would economize.
Replacing compressors?
No, we just did it as a test.
Could you envision a point, and if you could, what price point would this thing start to become a theft issue in the way that guys were stealing copper coils out of units?
Stealing R22, for the hassle, they'd have to be paying probably $30 a pound or more. I mean, there's a lot that goes into it. And it has to, I don't even know how that would work, but I've heard about refrigerant theft. I mean, there's caps. We've all seen the locking caps. There's a special key. So somebody's stealing it. Yeah. Somebody steals it. I just don't know who it is. I don't know what they do.
Well, and they're also using it to get high on too. So.
I think what they're doing is, you know what I think they do? I think they take it out and then they go resell it to a homeowner. They're not like we are. They're not selling it to Hudson for $12. They're selling it to Joe Homeowner or another business park for $100 a pound. That's what they're doing. Yeah. So we did that. We've done some conversions on Lieberts. We've done train and telepacks. We've done some Mammoth units. We've done some data air units. I'll show you some case studies here in a little bit. And just for your information, comprehensive contracts, C contracts, where if you're not familiar with them, customer pays us a budgeted amount, fixed amount per year, and we cover all the repairs. It's a budgeting tool for the customer. We used to cover everything. You blow a charge, we fix it, put the gas back in. The new language is that we'll cover the first 20% of the R22. The rest of it gets charged to them. Now, whether that's actually been enforced or done or not, I don't know, but that's the way the language was supposed to be changed. So just so you know, if you have any C contracts, some zones have a lot.
When converting it to 422D, do you have to replace anything?
We'll talk about it. Yep. So 422D, just the specifics on it. $8 a pound. It mixes with mineral oil or POE. You can use either. It's in that nice lime green cylinder. So you don't have to change the oil. Take out the R22. You can put this in there. We're considering a residential light commercial, but there is no paperwork that says that it is. That's what we consider it as our light duty, light commercial option.
So is this considered is this an HFC?
Yes. Yep. Because you can't skip HFCs with retrofits. We can't buy HFOs right now for unit systems. I'll tell you why, but yeah, we'll get into it a little bit. Yeah, but that's an HFC. Best to use it when on the small tonnage, there's a leak. You're not changing out the compressor, so a flat unit or the customer just wants to get away from it. That's why this building was perfect. Bunch of small tonnage rooftop units. take the R22 out, put the 422D in, and they've ran great. So it's nice and easy. The 407C, $6 a pound, a little bit cheaper. Pretty big difference from 6 to 8 over the long haul. Only works with POE. So that's your synthetic oil, only works with POE. It's perfect when you're changing a compressor or doing a major repair, or you're working on larger tonnage equipment that the customer wants to get away from 22. But you have to change the oil. It does not mix with mineral. As we all know, or we should know about compressors, they constantly kick out oil with the refrigerant, and that oil has to come back, has to get entrained with the refrigerant. And mineral will not come back with this. It'll log at the lowest or coldest point in the system, and that's where it will stay. Eventually the compressor starves and it burns up. The capacity, the pressures, they're all closer to R22. They're very close. What we want it, and we'll go through this again, the steps, but we want to get 80% of the mineral out so that we have 80% POE in. So that's where changing the compressor is ideal, because most of your oil's in the compressor. So you take that out, put the new compressor in, and now that's most of your oil change right there. So that's done for you. You can have a mix of mineral and POE in a system. They don't hurt each other. They don't fight. They don't contaminate. It's just the mineral is going to get stuck somewhere in the system, and it's not going to come back. So you got to get a good chunk of that POE in there.
How can I tell if I get 8%, well, that ratio without?
So there's some oil refractometers that you can use to, one, you can test to tell if it's mineral, AB, or POE. And then you can also test to see the quantity of each. The easy way in the field is you look at whatever that system charge was, you take the compressor, you dump the oil into the measuring cup. It's supposed to have 80 ounces. You got 76 of it, you're golden. So that's the easiest way, but obviously most compressors are heavier than this little Dixie cup, so it might be more difficult to tip it, but that's kind of the idea. If it's a semi-hermetic with an oil drain, you can drain it, you can measure it. That's how you'd know. The refractometer is probably something we'll have to buy some of. I don't know if we have any yet or not. Refractometer, yeah. So the process is going to be, and we're going to step through these step by step. It won't take that long.
How does a refractometer tell where all the oil is in the system?
It can tell you how much of each is in the sample that you take. So you open up the drain on the compressor, dump it in. It doesn't tell you where it's at. It just tells you what percentage of each is in your little sample. Yeah.
You're at the threshold there.
Yep.
Seth, do you ever use the R11 flush?
I've never used it. No. For
They
line
sell it
for
like-
line sets.
Yeah, I did it a lot in residential, actually.
Did you?
Yeah, so,
Yeah, you blow lines and oil out for 22 from
yeah,
410.
22 to 14.
Cut the
because
TX out,
Mostly, yeah.
put it together, blow it through. Makes sense.
Yeah, because most of the newer units.
Well, I remember when 410A came out. 410A is, of course, it's an HFC, so it uses POE oil. They said it was, I mean, you're going to blow up your system if you mix those two. And it's,
Yeah.
of course, through the years it's come out, it's really not that bad. You can mix POE and mineral, and it doesn't really hurt anything.
Yeah, I remember that
But-
too, and then Copeland came out with that tech note saying that it was okay to add R22 to the POE. And I'm like, wait a minute, didn't you
Right.
tell us?
Yeah, it was like forbidden for a while.
All right, whatever you say.
So when you do a retrofit, these are the steps. You're going to record the baseline data because you want to know how the thing's running. Because if it doesn't run right now, it sure is not going to run any better with something else in there, with a different refrigerant. So you need to know how it's running today. Take the refrigerant out, you weigh it so you know how much you took out. Drain the oil, record the amount if you're changing the oil. Add in the same amount of POE as the mineral oil that you removed. So that's if you're converting to the 407C. If you have a difference in elevation, so you have a split system, if your compressor's here and your evaporator's here, remember the evaporator's the cold part, then you have to add POE to the mineral oil to get it to come back, even with the 422D. We are going to try not to do split systems. I have heard nothing good about doing split system retrofits. But if you have to, we have some guidelines. I have some paperwork for you I'll hand out later that you can go home and read. But it talks about it. But we're going to try not to do split systems. Luckily, we probably won't have to do many. Replace the dryer. A new dryer is important. The reason is that what might have been caught in the corners and stuck inside the system with mineral and R22, now you put a different oil in there, a different refrigerant, that stuff's going to act as a solvent, and it's going to sweep it, and it's going to bring it back. So you want a new dryer, new filter to catch that stuff. That being said, the guys that did the conversions on this building, I don't think they replaced one dryer. I think they just pulled it out and dumped it in. It's kind of a test. And they've been fine for over a year. So. But you should replace your dryer.
Yeah.
We all know that. Replace rubber containing components. I'll go into that more in a few minutes. Pressure test. Make sure you don't have any leaks. Evacuate. Get the moisture out. Weigh the liquid in. Weigh the refrigerant in as a liquid. 95% or so of the original weight. You do that so you don't overshoot. It's easier to add a little bit than it is to take it back out. So you come in under, then you trim it. And then you install the appropriate sticker. And I'll show you the stickers here in a few minutes. So baseline data, we have this in tasking. It's in Mobile Tech tasking. You can ask for the tasking, retrofit tasking. Everybody good at tasking? Okay. Amps, pressures, line set temps, refrigerant line temps, evaporator split, oil level. We've been experimenting with thermal imagers to get the oil level inside the hermetic compressor. Yeah, somewhat accurate. Something to think about. If you can see the temperature difference of that shell with a thermal imager, maybe you could see the oil level. So we've been playing with that. Make sure it's running right. Take the cores out. Pull out the gas. Weigh it. This is pretty normal stuff. If you're converting to 407C, you're going to drain the compressor, measure the amount, refill it the same amount of POE. Remember, you're trying to get to 80%. That's what you want. If you're going to the 422D, the lime green cylinder, you're not changing the oil, but if you're doing a split system with a difference in elevation, there is a calculation to add some POE in there. But as you'll see, if you have to do a split system, there's more we're going to talk about and to make sure you do it right. For getting the oil out, they sell this little converter hand pump. I've heard it's a pain in the ass to use. I've heard it's very tedious, takes a long time. But you can use that inside of a compartment to pump the oil out of a hermetic compressor. You'd have to drop a line down the suction. So you're cutting the suction line, dropping the tube down in there and pumping the oil out. Kind of a pain in the ass if you were going to do it that way. If it's semi-hermetic, of course, you just use the drain. If you're doing a compressor, make sure you get it ordered with POE or dry. Most of them come that way. Replace the dryer, because you want a clean filter in there. Rubber containing components. So, remember this second C? Remember what that stands for? Chlorine. Chlorine makes rubber swell. So when you take out that first C, you put an HFC in there, those rubbers shrink back to the normal size. They don't shrink any smaller, but they go back to the normal size. Now you have a potential for leaks. So
That was the same with R12 to 134 with cars,
probably.
because all the O-rings had to be replaced too.
Yep, I would imagine. So you have to do all the rubbers. Leaks will, and then especially if you're going to a synthetic oil, if you ever put synthetic in an older car, it just tends to run out the bottom. It finds every leak. I put it in my Jeep, it just fucking ran right out the bottom. It's bad, man. I put normal mineral back in there and never leaked a drop. So it's a bad combination. So you got to replace your rubbers. So where are these at? Schrader cores, caps, valve body O-rings. So EPRs, reclaim valves, solenoid valves, got your little needle valve, you got your body gasket there. If you can rebuild these things, it's super easy. If you have to cut them all out and braze them in, it kind of sucks. But if you can rebuild them, it's not bad. It's just a matter, like on these, most people have rebuilt a solenoid valve. You just unscrew this bonnet, lift it up, replace the O-ring, put it back together. You already got the gas out, so no big deal. You don't even get your torch out. But you have to replace the rubbers. Otherwise, you're going to have leaks. And that's true for 422D, 407C, all of them. So part of the process is knowing where the rubbers are. Ball valves, you may have ball valve, you may have gaskets down in here, you may have gaskets over here on the Schrader cores and caps. So you need to identify where all the rubbers are. Compressor terminal gaskets, we're still experimenting with these. Copeland K bodies, Copeland 06Ds. If you can tighten them, then that's fine. Because remember, the O-ring, all it does is shrink back to its original size. So you just tighten up the terminal stud, and it's fine. If it's a hermetic compressor, it's fine. Those aren't adjustable. They don't have O-rings in them. So it's something to keep in mind. Try to retorque those things, tighten them up. Teflon paper and steel aren't affected, so rotolocks, those are fine. That's a Teflon seal. That makes it easy. Try to rebuild the solenoids, and you may need to ask for a parts breakdown. So like on compressors or call-up trains, say, send me a breakdown of this unit. Most time you just look. You can tell, you know where your valves are in a system. See if there's any rubber in there that needs to be replaced. Standard package units, that's Schrader cores and caps. Nothing to it. Liebert, probably have a liquid line solenoid valve. Not much more. As you get into the bigger stuff, you're in telepacks and things, you're getting some more components. 3D scrolls, you can tell these are just telepack. They got that kind of funky head on the top of the compressor. They struggle when you change the oil. So what you have to do is you have to put a crankcase heater on them. You see this one doesn't have one. Looks like it's laying here. And you have to put a check valve in the discharge line. Most of the time these things are tandem. They come together. The discharge lines come together. You put a discharge valve on that common discharge line. Because these things, if you know how a scroll works, they don't have valves. So they have a discharge check valve up in here, inside the head. Those things tend to leak. And it gets worse when you change the oil or go to an HFC. And so what happens is these things fill up with liquid refrigerant, or that refrigerant migrates through the compressor and builds up in the evaporator. Then you kick it on, all that refrigerant that's down here inside the sump, what's it do? Flashes off. It kicks all the oil out. Now you got a compressor running dry. So those are some things to think about. Right, Mark? You were going to say that, huh?
I was thinking, you guys are like goddamn surgeons with this thing.
So,
I can't believe all this
pressure
stuff.
test and evacuate. Normal, evacuate it down below 500 pounds, 500 microns. Recharge, we already talked about it. Weigh it in, come in just under, then trim it. Superheat, subcool, normal stuff. 22D and 407C, they are blends. If you haven't worked with blends, PT charts are a little different. I'll show you the example in case you don't know what that looks like. You use a dew side for superheat, bubble side for subcool. If you have any pressure controls, head pressure, low pressure, when you look at these charts, so R22 was a single component blend, right? You had one pressure, one temperature. Super easy. These have a glide because they're components. So over here, 100 degrees equals 212 on the bubble, but 198 on the dew. So if you're setting a head pressure control, you put it in the middle. That's how that works. You just split the difference with your pressure controls. But when you're charging to these, make sure that you're using the proper side. So you're using one column here for subcooling, and you're using the other column for superheat. But these canisters, they come with the pressure, the TP charts, so that's no big deal. New cores and caps, conversion stickers. we have a bunch of stickers made up. They say McDonnell Miller. For service call, 407C. It's the color of the cylinder. So it looks nice and fancy. When you did it, what oil, how much refrigerant you put in there. That's 407C, and this is the 422D. Lime green, just like the cylinder color. So we have those available. If you guys want to take some, you can certainly take as many as you want. You're welcome to do it. There is a workflow available, the location updates. So you would run that so that we know that it's been converted. We have a record of it. Complete the the mobile tech tasking. So new compressor draw, new amps, or new volt, just all your data. Splits. And then a return visit is advisable. So if you do one of these, come back in a few days and check the oil level. Because we found that often, as that mineral oil gets kicked out in the system, you're going to be low. So it's a good idea to come back and budget that on the front end so you're not eating the cost later on.
What does, what are these units, I mean, running in low ambient conditions? I mean, it's already an issue with R22 and you can't get your head pressure out if they don't have head pressure control on, but, I mean, have we seen a lot more issues with the new refrigerant?
Yep. Yep.
Well, the oil gets trapped in the evaporator.
Some are worse than others. Yeah. It is a problem. That's why make sure your head pressure controls are working and make sure your economizer switch over is correct. Don't have that compressor on when it's 50 degrees out. Don't set all your enthalpies at D. It's basic economizer theory. Make sure those things work. It's not difficult. You need a refresher so you're forming on economizers. Or I'll draw you fancy little pictures on the board if you want. We can do that too.
After the class.
So some other info just to finish up. If a building's partially converted, don't go in there saying McDonnell Miller only lets me do 422D. We don't want to mix. Last thing we want is 427A here and 422B and 422D and 407C and 421B and all these others. Be consistent. You can go buy whatever you want. No one's going to slap your wrist. Just try to stay consistent. We actually have stickers for all the other refrigerants. They're already made. Yeah, we already have them. So be consistent. We don't want to try to put an undue pain to the customer or on you. We haven't tested these with heat pumps. So don't go out there selling every hydronic heat pump in downtown Seattle on a conversion. Please.
Yeah, salespeople.
One
in the works to test them.
Yeah, we need some samples. So
I got a bunch of C contracts.
yeah, I bet. One of the things that we don't know about heat pumps, we know they'll work fine in cooling.
Yeah.
I don't know about heating. Like, they have lower discharge temps. I don't know if that translates into lower output or not. Because I don't know if that's sensible heat coming off your compressors. I don't know how much that is work going into your airstream versus the latent heat as it condenses from a gas to a liquid. I don't know. We just have to test it. I have a spreadsheet going. So every conversion is supposed to come through me as far as the startup data. And then I put it into a spreadsheet so I can track it and know what happened, what led up to it, how it ran after, what parts were used. Because if it turns out that we start wanting to do a ton of IntelliPacks, well, it'd be nice to know what parts we need. Or Mammoth self-contains or whatever. So try to feed me that information. Yeah, send that to me. And then, so know what refrigerant's there, stay consistent, what type of compressor, what oil's in use, if there's a difference in elevation, is it a heat pump? Know that stuff. There's a basic form. Let me see, I think that's about it. I'll hand that out in a minute. We were gonna do a field proposal for quoting these. We haven't done it. Because we determined that we didn't want to be quoting every unit out there for a retrofit. It's only just when it makes sense. So that's the ones we've done so far. We're trying not to get into the retrofit business. We just want to have it available for customers. And
Do you
then,
remember
yep,
those
number
ones- Those ones over at Internet, those train splits?
Yep.
You know them quite well now, don't you?
Yes, I know
Well,
about
that
those.
was, the evaporators are 2 stories down. Is that why we're kind of sketchy on wanting to do splits?
Yes.
Was that 422? That the person
I
used?
think Justin put in 407C.
Okay.
He was-
And
I
then-
wasn't gonna name names, but.
And
He was
then,
a- he- he was
I'm not
a
gonna
big
say a
fan of
last
407.
name.
Was it
It could be
407?
any Justin.
Gotcha. He wasn't a huge fan of the 422 or the Mill 99s.
Yeah, and he'd go in for hours, why,
Oh, yeah.
why.
I've listened to
hard
him
he went
before
by
that.
that.
So, I don't wanna hand this out, cause I didn't want you staring at it instead of me. I like it. I like eyes on me. So the first page, we got a handful. Oh, Jimmy Hotel. Hey, Jimmy. Got a few people on there. I'll hand these out. This is a little packet to you guys on the Skype. I don't think. Get to that in a second. So there's kind of it just says kind of what I just told you, but it's kind of written out, but it's also written for customers and salespeople, kind of what we're doing, but it doesn't get into specifics as far as like ball valves, heat reclaim valves, whatever. On the back side is a form. These are the kind of the questions that you need to know if you're gonna be converting. All this is on the Dropbox too, so if you don't like paper, you don't have to take this. I just wanted you to have something to look at, but you can look at it on your iPad as well. But know the answers to these questions, because this is stuff you want to know. You want to know if you have a liquid line solenoid with a rubber seal in it. There's a service update from ICOR talking about EEVs. Electronic expansion valves look at the pressure and or the temperature of the suction line or more. They have a built-in TP chart into their brain. They do the math and they adjust their stepper motor based on that temperature and pressure. You take out 22 or whatever's in there and you put in something else, there's no way to tell it that there's a new refrigerant. So now that thing's off. It doesn't work right. So if you have EEVs, you need to look a little more closely and see, can you change the mapping profile of that stepper motor? Can you tell it what the new refrigerant is? Because if you can't, you're going to be screwed. So know that.
So no ductless splits, no city multis.
Yeah, how many?
You go convert a bunch of R22 city multis. Jesus. Fushing compressors. I know some of you guys love Fushing compressors. Hitachis are very similar. This was an email from Don over at AC Components. If you're going to convert Fushing or Hitachi screws, read this email because there's a specific POE they want you to use if you're converting to 407C. And then this last one, I'm going to put it up here so you guys on Skype can see. It'll be easier and probably in front of you, but there it is. So I know Jimmy's on the Skype, he'll recognize this. So this was down at, and actually maybe Josh has been there, but this is a Savvy data center down the road. That Jimmy just did a ton of amazing, awesome, efficient, high quality work at. He did a good job. They replaced a bunch of coils and they're testing 407C because they have a lot of data air systems. And these are all splits. So these are all condensers up on the roof with the data airs down below. So the compressors are down below. So pretty ideal situation, really. So what we did, Jimmy did the conversion, and then we had Tab go in, and they went in on 2 identical units. One is an R22 and one was converted to 407C. And we had Tab go in and so this is crack 2 on R22. These are the readings. So we have discharge air, and then the delta, we have wet bulb, dry bulb, RH, grains, enthalpy, bunch of stuff. Compressor amp draw. What we're really concerned with is our total BTU, because this is our capacity, right? We're concerned with capacity and our amperage. So this was the unit running on R22, and then the sister system next to it running on 407C. So that was 303, 389. This is the 407. We actually had a gain. So we actually picked up capacity by going to 407C. We had a slight uptick, I believe, in compressor amps, but we had an increase in capacity, so that's pretty good. Now this unit had a indoor coil replaced. I don't know if the other unit did. Maybe Jimmy can chime in. I know if he talks, you can hear him. But
sorry, no, neither coils were replaced.
That's pretty good proof that not only is it working, it's working better than it was. So that's something. It's in your packet, so you can look at it in more detail if you want. And I'd like to get more of these done as time goes on, because that's pretty good for the customer, because they got a bunch of these things. So now we can start doing more of these conversions over time. The last thing, since you guys haven't got up and left yet, any questions on the retrofits? I mean, part of it's going to be when you come to it, asking questions, asking me, asking your foreman, whatever. Link, small repairs, they're all up to speed on these. They've done some. So the new refrigerants we're looking at that are coming into the market, the HFOs, hydrofluoro olefins. Train has a pony on. They've picked their pony. They're like 514 or something. Is their HFO? York is using like 1233YZ, I think is what it is. There's a bunch of different ones out there, but they're low on the global warming. They're low on the ozone destruction. The problem is some of them are mildly flammable. Mildly. So what ASHRAE did, ASHRAE has come up a few times tonight. ASHRAE created a new classification. This was the classification scale for years. A is non-toxic, B is higher toxicity, and then 1, 2, and 3 goes up as it gets more and more flammable. So R22, propane. I think ammonia is right. I think this ammonia is like a B2. They had to create a new classification because these HFO refrigerants, they're difficult to ignite and sustain. So if you took a jug of HFO and put a lighter to it, it probably wouldn't light. But if you were to like vaporize it or heat it up, you could get it to light, but it won't sustain. So it doesn't continue to burn on its own. So the good part is that it doesn't continue to burn. The bad part is it's slightly flammable. And do you want that in your VRF system running through miles of refrigerant piping in your building? Building codes haven't adopted it yet. So that's like York, they haven't installed anything with that 1233YZ or ZE or whatever the hell it is. Train hasn't installed anything with the 514. They're waiting for the building codes. So what's probably going to happen is building codes are going to adopt and they're going to say, yes, you can use this. You can use your A2L refrigerant, but it needs to be in a central chiller plant where you can control the environment. You can have fire suppression. You can have exhaust fans. You can have barrel relief vents that are piped to the outside. You can have interlocks between that and your boilers. So if something happens, you can control it. And then they'll probably eventually move into package units where you have this in the airstream, because this is going to be in your evaporator. And then eventually, I don't know, maybe your VRFs, but we'll see. But HFOs, right now they're in the cars, but it's a fairly small amount. I mean, they're 10 ounces, I don't know. They're a small amount, not hundreds of pounds. So, Waiting on building codes. We'll see what happens. We don't know what what Trump's going to do though. So with the whole EPA thing, they've lost funding. We don't know. All this could be for nothing. But the thing is it's easy to say that, but that's just the United States, and they're not the biggest market in the world. There's still China and Europe, Japan, and the manufacturers have already dropped 22. They've already dropped 410A. Like they're moving in a different direction already. So even if the U.S. was to allow all this stuff to come back, I mean, the major manufacturers, they've already moved on. Like they've already invested millions into these HFOs, so it doesn't really matter. Yeah, that's pretty much it. I mean, if you guys want to keep talking, I'll keep talking, but it's up to you guys. Those are the main ones that I wanted to talk about. There are some new leak rates coming in 2019. We're gonna have to start repairing stuff that we don't now.
Is that part of the EPA 608?
Yeah, the new 608 rules, yeah. Yep. You have to do follow-up verification for leak checks, but we're a year away. Right now it's gonna be over 50 pounds is what it is.
So what's the blue on stuff? Is it just another name for one of those other refrigerants?
Yeah, so Blue On TDX20 is what their trade name is. It has an ASHRAE number, R4 or something. It is a multi-component blend. What they sell it as is that you can take out R22 and you dump this in just like 422D. Same thing. They claim higher efficiency. They claim lower operating cost. They claim you don't have to replace any rubbers.
That's big.
That's what they claim. They recommend it, of course. They say you should, but they say you don't have to. So I don't know. The problem with the Blue On is that unless we do it at a building on campus, like how do you tell a customer to try it? I mean, we'd have to back it up pretty substantially. Like say, we just want to dump 50 pounds of this in your system and see what happens. And then what if it leaks?
Like two split systems up in the gym area, or one split system in the gym area, you can throw that in?
Probably could, yeah.
It's like a York unit,
What refrigerant's in it?
410, I think.
No, we couldn't.
Because it's POE on it?
No, because 410's not Blue On and 410 don't mesh. They're different components. Yeah, different pressures, different everything. Yeah, because Blue On's an R22 replacement. So yeah, I don't know. We bought a 4-pack of Blue On. Blue On runs about $20 a pound. Right now, it's barely cheaper than R22, barely. Until there's a bigger difference there, it's going to be a tough sell. But it is an HFC, so if a customer wants an HFC, and Leonardo DiCaprio is their spokesperson, so they got that, which is serious. You go to their website, it's a picture of Leonardo DiCaprio saying this stuff's awesome. It's fucking weird. Because he knows. Yeah. He knows. Of course he does. Like,
Well, it took him 20 years to get an Oscar, yeah.
to get an Oscar.
Crazy.
Well, Oscar gives him a lot of qualifications.
Well, so does his yacht and his...
Captain Kirk and Priceline.com.
Yeah.
He's an investor.
Look what that did. Well, so yeah, I don't know. We did buy the Blue On. We wanted to have some. We got certified to buy it and sell it, so that we had an option for customers like CBRE. So if CBRE comes to us and says, "Here's what we want," we can say, "Yes, we'll do that."
Yeah.
And we can today. We got it sitting out there. We've put it in a system over in Bellevue at Washington Square, and it's going to go in the second circuit of the same unit probably next week or so. So that's kind of our test. But I don't know, I don't know how much follow-up we're going to have on it. I don't know if we're going to be doing tab reports. Eventually, maybe.
It's already, sounds like you've got all the detail on it.
Yeah,
Trying it, and
we've made an effort.
Yeah.
So,
that's
all right.
awesome.
Thanks, guys.
Yep.
Thanks.
Thanks, Seth.
Take your packet. If you got any questions, give me a shout. You know where to find me.
Actually, we'll take a couple of these.